Welcome to the Foundation for the Study of Cycles. My name is Lars von Thienen, and I'm a member of the board of the Foundation. And this Monday, each Monday, every week, we will talk about cycles. So today, the topic is about detrending. So this is an important topic in regards to every cycle analysis. So we talk about special pre-processing before you put whatever cycle analysis. So we will not dive into concrete market examples today, because there is no real change to the cycles we showed anyhow. Today is a special topic on detrending techniques and why detrending is important for almost all data series. And it's often an overlooked topic you need to be aware of, and you also need to have in mind when you look at the detected cycles. So therefore, let's directly jump into the session today on detrending. So to talk about detrending, the first important point we will make is we will use an example data set, which I've prepared here. So first, let's look at this data set to see what's special about this data set. So if we have a look at the example data set, which is shown here, this is not a real data set. So this is constructed based on 5 cycles, which are listed here on top. So this is a composite data set based on 5 different cycle lengths with different amplitudes. And in addition, there is a lot of trend embedded in this data set besides these 5 cycles, and a lot of noise. So this is what you often find in markets, this kind of data set. So the first important point is for cycle analysis, we need to get rid of the trend. Yeah, and the five trends which are embedded in this data set is a linear downsloping trend here. Then we have a sideways trend. Then we have a strong uptrend, and then another downtrend. So this is known because this is a constructed data set. So we have 4 different trend elements here in this data set. And one of the most overlooked topics before applying cycle analysis is that you need to be able, in your pre-processing techniques, and then the technique which is embedded in the cycle analyzer, which you can use here, is to detect those trends. Because if you don't remove the trends from this data set, this is what will happen to this data set if we, if we bring this to our cycle analyzer here. So, first, let's look at the wait a second. Where have we gone? I want to show you the spectrum. Okay, here it is. Here, so this is the spectrum on the left-hand side. So if you put this data into the analyzer, you will clearly see, or we can even do it here, you will clearly see that there is almost, it's almost hard to detect which cycle has been detected in this data set. So lots of cycles might show up in the spectrum. You know, the 5 which have been based, which would be important, are not clearly seen in this data set. So therefore, let's get rid of where's my mouse cursor? Okay, so let's remove this one here. So, and even more important, as we don't analyze these 2,000 data points which are shown here, the most important point is that you only analyze portion of this data set, because you don't have this long history and we don't do scientific research. We want to get the cycles for forecasting. In this example, we even just use the first, so this time frame here. So we just use this period here, yeah, for cycle analysis. And this is the spectrum, which is shown here, which results from this time frame here. So where you see, by just analyzing the first portion of this data set, we are not able here on the left-hand side of this analysis, give me back my, on this analysis here, to detect any of the important cycles here. So that's the basic approach, and sorry for getting this, this kind of crazy here, but this happens without any detrending. So you won't find any clue of this spectrum analysis here. So pre-processing is very important, because as you see in this spectrum here, there is almost no clear indication which cycle to use. Okay, so therefore let's move forward in our example here. So let's continue. So this is the trend. So, and if we would, by the way, just an example, if we would use the cycles from, so just the top cycles which have been detected here to forecast this period here on the right-hand side, this is how it would look like. Yeah. So this is using the standard spectrum analysis, which you've seen from the first 400 chart, just selecting the top 4 cycles, which, and this is now important if you see a composite on the left-hand side, yeah, you see that it really looks nice in regarding assigning here the tops and the bottoms of the cycle. But here starts the out of sample period on the right-hand side. So, and there's almost no indication about, oops, I want to, yeah, so here you see this is the low here. It's very nice aligned on the, on this side here, and here the top and the low and the top and the low here, and even here the top. So even the composite looks very good in the in-sample data by selecting the top cycles here. You almost have no clear view here on the out-of-sample data here. So as the out-of-sample period starts at this point in time here, there's almost no predictive usage of these cycles here. And this is one thing is, I mean, even though the cycle length in some cases might look good from the detected cycles here, but the other topic, which is always important, is the phase is completely off. And if the phase is off for those cycles here, you won't have any predictive value here on the right-hand side of this data here. So this happens if you have bad pre-processing in your data. You now see a composite which is completely out of any predictive value, even though you won't be able to spot this in the in-sample period, because the composite in the in-sample period looks good. Okay, so now let's get rid of this example here, just using the non-detrended version. So now what we see here is we apply now the detrending function, which is embedded in the cycle analyzer. So this happens as a standard feature. So the golden or the gray line here is now the trend in this data set. And if you remember, as I've shown you what trend is in this data set, so we had the downtrend, we had the sideways phase, we had the uptrend and the downtrend. So we know this because this is a constructed data set. You see how exactly this detrending algorithm is able to pull the trend out of this data set. So, and I can't stress enough how important this is, even if you have the best variant of Fourier or spectrum analysis. If you do the wrong detrending here you won't get any predictive clue out of cycles. So I just want to show you here that the Hodrick-Prescott filter, which is used in this example here, needs a little bit some tuning, the smoothing factor, and there is a boosting function in here, but it shows you that it's quite able to spot the trend function here. And if you now remove the trend from the data, this is now what gives you the detrended data series here on the bottom now. So you still see this is the trend component here, which has been extracted from this data. And in the bottom panel, you now see the detrended, so only the cyclic composite component of our data set. And this is what we need before we apply cycle analysis. So at least it's the same data, we just remove the trend. And this is one of the best detrending functions you can ever see, even though during the last years there's a lot of criticism on the Hodrick-Prescott filter, but I would call it still the gold standard in economic market analysis. And there are even some new papers on it, which anyhow propose that it's still even better than other sets here. I will get back to this in a second here. Okay, so now we have pre-processed our data. And now let's check how different the spectrum would look like. So the full data set gives you now this spectrum here, which is shown here. So I think it clearly shows you that if you remember the first spectrum which I showed you, that you clearly see one. So let's highlight this here again. You should now see clearly, my God, 5 clear peaks in this data set, right? So here we have 1, 2, 3, 4, 5. So now, compared to the first spectrum I've shown you, which used the raw data set, where you have lots of peaks in the spectrum, now by using the detrended version, it is clearly able, and if we go into the details, it's able to detect these 5 cycles more or less very exact in regards to amplitude, length, and phase here. And now there's no discussion about which cycles are in this data set or not. I mean, this is a composed data set, so even though real market data is not as clean as this example here, but it shows you just the difference from not using detrending functions and using the detrended function. And you also see how sharp these peaks are in the spectrum. Yeah. So this is what's the ideal way how a peak should look like. So even though in real data it would not be this clear peak, but if you maybe remember the previous data set where we had the first spectrum, which was this one here. So just to give a quick comparison. So this was the first data set where we did this. You still see the peaks, but you see a lot of noise in this data set. And even though you don't know which of these peaks here to detect, versus now the this version here, which gives you a clear indication about what cycles are in this data set, right? So, and now let's shorten now the data set again, because I said we never analyze the full data set here. So therefore, let's go back to just using a fraction of the data set here, which gives you then this spectrum here. So again, I will put this here in the upper right. So just using the first bars here in this data set. So now using again just this data set here now, as we did in the first example, as a fraction of this, gives you now this spectrum plot here, right? So and this should show you here also that there are now 4 peaks available, right? So now we are able to see these 4 peaks here in our spectrum versus in the upper right corner where we had the 5 peaks. So just with a length of 400 data points, just the longest cycle will not be visible. And now let's do a projection again based on these cycles here. So now we choose the these 4 peaks in the spectrum, and we will do a projection with our cycle scanner, which is now shown here. And wait a second. So this is now how the projection looks like if we use just the 400 data points from the detrended data set. You see here the projection line ends here at this point in time. So, and the light blue one is the projection area, where you now see that even though on the left-hand side, same as before, we have a good fit of the composite in the in-sample period. And now if we just pick, again, just the first 4 cycles here on this list here, which is always the standard procedure without any other methods putting into the mix. And you can observe it's somehow similar cycles which have been shown up here. So these 4 cycles are now very exact. But more important than just the length is now we have the correct phase detection of these cycles, which if you have a closer look on how this now aligns with major tops and bottoms, you can see here now in the out of sample period how nicely now this was able to spot the future tops and bottoms here in these markets, which was not able by just using the raw data series. So here you now see the clear difference by using the forecast of the spotted cycle from the detrended version, which gives you even in the out of sample period now the good turning points. And just comparing this to the previous version I showed you here. So this is the same procedure with the marks we did with the raw data set in our cycle analysis. Also just selecting the top 4 cycles which have been detected. And again, you see on the left-hand side that the composite in the in-sample period is aligned with bottoms and tops of this data set. But as soon as you get to the out-of-sample data, you see that the full composite is out of sync for any purpose of projection or forecasting. So that's the important point I want to make today, that even though it's not visible to you, the detrending of the data series is even though somehow more important than any Fourier or digital signal processing at all. So we've never talked about this, and there's always then the noise about how can we improve the Fourier transformation, or why should we use other methods here? And I think we must more talk about and bring the knowledge even across that the right detrending of your data sets is a key for every following digital signal processing, getting the right cycles. And not only getting the right cycles, it's even more important for doing projection lines we can trust. Yeah. So even though Fourier might be able to detect the cycles on raw data sets, which looks good in a composite on the in-sample period, but then using this projection on the out-of-sample period, you see that the better the detrending upfront, the better the quality of the projection line. And that's why we also don't offer any option to change or switch the detrending function. So it's just a feature which happens by itself. So, and the Hodrick-Prescott filter, by the way, is the most important, and that's the gold standard, at least in all economic science papers, if you read about this topic. So you can be sure that we have this filter embedded, and you need to understand that the cycles detected always represent the detrended version of your data series, as shown here on this chart. Yeah, so the composite is always looking on the detrended data while the trend is taken out of account. But you also see in the upper right corner, so this is the current trend of the data set. This is not shown yet, so this might be important for your projection line, so that the current trend at the last point of the data set looks like a slight downtrend we are in here. So you should be careful with using cycles against the trend. Yeah, so you need to be aware of also where the cycles happen in your current environment. I mean, there are other methods to check the current trend. The detrending is important to also detect different trends in your data set. So it's not just one linear trend over the whole data set. There might be different trends in the past. So that's why the Hodrick Prescott filter is able to detect different trends. But if you do your projection line, you should always have a clue about what's the current trend, because you should always be careful with using the projection against the current trend. So this could result, if you follow an uptrend phase of the cycle, in a longer downtrend, which might result in a sideways move in your overall data set. So this helps you maybe then to look out for cycle projections or turning points in the future, which go in direction of the trends. So it would be interesting in this theoretical data set here to look for cycle tops, which lead then to downswings in the cycle, which is then in alignment with the market trend. Okay, so that's always important to take into account. So now finally, let's have a close or short look at other detrending methods, just to complete the session for today, to give you that you're aware of what happens if you use the cycle analyzer. This is also another method which is used, and some argue polynomial fitting, which is a regression method based on polynomial trend fitting here, is often recommended, but you see, as we know the trend here, that this is not as good being able to detect these linear trends. I mean, you see, it's more this cyclic move here, but it's not as good as the uptrend, the sideways trend, and the downtrend. It's even suggesting here a slight uptrend in the beginning, which is completely wrong. So polynomial trend fitting might be good from data science perspective, but if you deal with these data sets, we have got to the result that it's not good. And another way, also very prominent in these research, is the cubic splines, which is also a very new method, which also looks nice, but has also some shortcomings. And you see here it's suggesting a sideways move in the current data set, which is wrong, because we know how this data set was built. There's just this downtrend, and it's a little bit cyclic here in the beginning, so not clearly showing the trend. So we did our work at the foundation to compare different ways to detrend data, and there's a reason why we still use the so-called gold standard in macroeconomic time series analysis, which is the Hodrick Prescott filter, with a special smoothing factor in addition. But I hope this shows you a little bit what happens in the cycle analyzer. And if you're not using the cycle analyzer, this is at least knowledge you should have in mind or keep in mind if you do your cycle analysis with whatever application or frequency analysis techniques, that you need to do the pre-processing first. And this is often more important than just cycle detection. And this is, by the way, a lessons learned in data science anyhow, which is not seen. Data preparation, data pre-processing is in most cases more time consuming, but in the end more powerful if you do it right than the basic analysis routine you apply to your data set. So therefore, it's not spoken often on this topic here, so therefore I want to dedicate this session on detrending. Okay, so as this is a special session today on this special topic, let's now keep a look on your questions. Tony, I think not much questions for today. So maybe an unexpected session for today, as we in most cases just analyze the markets. But I wanted to bring this across. And Elliott Wave is not part of our tool set here at the foundation. So Elliott Waves is a special pattern, I would say, not pure cycle analysis. So therefore, we are not experts here in Elliott Wave, which is, by the way, not very subjective also in detecting the right ones and twos from where to start your counts in Elliott Wave. So therefore, that's not a special topic we want to talk about. Okay, so feel free to drop your comments in the chat section, even though about different methods of detrending. And please be aware that this is a special session for today. Next week, we will pay attention to the markets and the cycles in the markets again. So hope to see you there. Thanks for watching today and see you next week again. Bye.